All right. First question: how many teachers are teachers, be it a homeschooling parent or traditional teachers, do we have here? Okay. All right then. And then how many students? How many folks are actually participating in the contest or students? Okay, all right. Well, let's make sure Leslie can Leslie Martin, can you hear me? Raise your hand. Can Leslie Martin hear me? Hmm. Let me send this out mention. I'm gonna do this. I'm just gonna see if I can get everybody. All right. We're gonna go ahead and get started. I just sent that message out for people who can't seem to get on or can't hear me. All right. Last week, we're going to go ahead. We're recording now. Last week, we did the first 5 or so lessons, and we talked about Fly to Learn. Fly to Learn is part of is a curriculum developed out of X-Plane. We want to teach kids the engineering process. To do that, we have to teach the scientific method, which we do, and we also want to encourage people to look at the aviation industry. All right. So that's what our goals were. Good. Glad you can hear me. Now, everything happens when you set up your flights. So let's get an X-Plane 9. You bring it up, look under settings. You want to get in a quick flight setup. That's where it's LAWI and general aviation occurs. And over here, visibility. That's all part of this whole arena. You select your aircraft down here. Make sure you select your time. All those good things. That happens there. When you go to take off, we're going to go. Remember, we went through 3 things we need to do. We need to pause the airplane, turn off the brakes, push in the throttle. Use the arrow key to go down to see it if you can't see it. And go down the runway, and we went ahead, and that's how we were taking off. We learned under settings to look under data input and output. We realized we could collect speeds, distance traveled, landing gear, vertical forces, the graphics and cockpit display. And indeed, there they are. And so when you're in the cockpit, sometimes you don't see, like right here, see these, you can barely make it out, but there are numbers here. You have these instruments, that's what all pilots have, but these give you much more detailed. And we can collect about, from this picture here, you can see there's 131 items we can measure on the airplane. Just as maybe way more importantly, we can graph this. So depending on what we're looking for, we can graph it over time. And in this case, we've turned off much of this, and we have V-true, airspeed, distance traveled, and our landing gear. Those are really the 4 things we measure most of the time. And remember, we said when the landing gear loads are at 0, we define that as takeoff. And then we went at wing loading. Excuse me. We talked about weight. We talked about lift. We talked about drag. Those are the forces behind that. And you have a series of lessons where you collect data, you measure data, and you make determinations. Okay? Any questions about that? If you didn't catch all of the first lesson, next week we're going to be on airplane design. That won't be a long lesson, so if you've got questions, you can come back. Also on the Fly to Learn YouTube channel, we have the webinars. We'll post more of the webinars back up there. Now, normally this is when we go into 6. And I would say, but I want to show you something, because sometimes depending on the class, like if it's a younger class you're dealing with, you might just go through lessons 5. They learned how to airplane fly. Super. Older kids, hey, we want to teach them the engineering method, we'll go there. But I'd like to break it up. I don't want the kids just constantly flying on a computer. So one inexpensive way to do this is to get these little Jetstream airplanes. If you're a certain age, you remember growing up building these things. And here's one right here. It, you put it together in less than 5 minutes, and it'll fly less than 2 seconds. And this one's finished. So you ask the kids, well, what can we do to make it fly longer? Hopefully, you've just learned about how weight impacts an airplane, how drag impacts an airplane, how lift and thrust impact an airplane. And they're going to make some suggestions that's going to result with the airplane not having a cockpit anymore. Get rid of the guy, get rid of landing gear. That's just drag and weight. And then maybe replace this motor, if you can see down here, with a bigger motor so you have more thrust. What they haven't talked about, what you're going to show them, is we're going to add some stability to the aircraft and the design itself. If you do all those things, you can get a 5 or 7 second flight. It's significantly more. And it really demonstrates the things you're showing them actually apply. The real world, and they work. All right? Now, we are going to go ahead. I'm going to pull up flight lesson 6, just for the sake of, so you all see where you can get these lessons. I'm going to pull that lesson up. There's my webinar software. Let me do a new tab. Pull up Fly Learn curriculum. If you look under Fly Learn, go under educators right there. You're going to get lessons. Go down to lessons. All right, here they are. In this case, we're going to go to 6, PDF, down it pops. One mantra we have throughout this is the Wright brothers were engineer first, pilots second. They're incredible engineers. They're pretty good test pilots, by the way, too. If you think about it, they were originally test pilots, and how hard that would have been. You don't know if it's your design or your ability to fly the airplane. Okay, so there's a vertical axis, lateral axis, and the longitudinal axis. And that's where we control an airplane. And we have roll, it's just what you would think of roll. Then you have pitch, think of up and down on a boat. The boat pitching on the sea. And finally, you have yaw, and that's left or right. Okay? The whole idea, so what you do is, first thing you do is have the kids get on their airplane, sitting on the runway, and they just change the controls of the airplane so you can see these different parts change. When you go ahead and you pitch the airplane, what is the elevators doing? When you roll the airplane, what are the ailerons doing? That kind of thing. Now, we need to talk about, in the airplane, the reason you have the wing, the tail, and that's for stability. And the best analogy still is an arrow. If I took an arrow and launched it, if it goes 2 feet, if it's a target, I'm only 2 feet away from the target, it'll hit the target. But if I go any real length, it'll begin, and I don't have feathers on the tail. I don't have feathers on the arrow. So I don't have really a tail on the arrow. It will tumble. And it'll just be out of control, and you don't know what's going to hit. And you certainly don't know where it's going. Same, and that applies to an airplane. And what it does, it has an impact. That tail on whether it be it on the arrow or the airplane, acts as a negative. It's a dampening mechanism. It's a negative. It creates a negative feedback loop. If the plane is being pushed to the left or to the right, this is going to cause the airplane to want to move back towards the left to cancel out what's going on. And if it's pitching down, it's going to cause the airplane to pitch up. That's why we have a tail. It's all about the stability. And that's really important for a pilot. You've flown 3 hours. You still got 45 more minutes into this flight. You're exhausted. She's a business manager somewhere. She's trying to come in. She needs the plane to fly itself as much as possible. And really well airplanes do that. The exception, obviously, that are combat aircraft or acrobatic state. You want them super maneuverable. And remember that balsa wood plane, we gave it a tip dihedral. All right. Now, here's something that honestly, I'm not sure all the pilots know how to do. It was true. Everybody talks about, if you know anything about model airplanes, they talk about the center of gravity. That's the point at which the whole plane bounces. What people don't realize is you don't balance the plane according to the center of gravity. You're really trying to balance the airplane. You balance the airplane on the center of lift. The center of gravity is usually a little bit farther ahead, and we're talking in inches. And it's the center of gravity moment arm. It's the force of that center of gravity all the way combined, and the distance from the center of lift gives you the center of gravity moment arm. The tail moment arm comes from the tail to that center of lift and the load on the tail. Okay. And what you do is by changing just a few inches that center of gravity, you can make the plane stable or really very unstable or unstable. And that's kind of what we end up doing with this. We go up there and we start to change, and as you dive and fly, we want you to see how it corrects for itself. Let me just give you an idea. Wait a minute. Let's see if I have it here. I'm going to pull it up off of here. Bear with me. We'll pull up X-Plane. It's going to come up. I'll just show you this on X-Plane. You'll see it. While this loads, any questions? Oh, understood. Apparently, I'm running another copy of X-Plane. Let's see what's going on there. Well, I hate it when the computer's right, but it is. Oh, but there it is. Well, no, I don't want to. Here's a plane we're talking about. And it's certainly going to. All right, so I'm going to do settings, quick flight setup. I'm going to go final approach. Here I am coming in. We talked about landing last time. I'm going to pause this. Okay, understood. All right. Now watch this. Under the question mark, I'm going to put vectors. And you can see, watch the back vectors as the front vectors get greater. Watch. I'm going to pause it. It's going down, last lift. Now when I pull up left, look at how the back reflects what the front's doing on there. See, when it dives down, it's even a reverse of that. Well, I'll make sure I don't crash this. That would be kind of a bummer. All right. See, great lift vectors here, great lift vectors off that tail. So load on the tail. So it balances. All right. And that's what makes the whole thing pretty exciting. All right. Okay. Any questions about that? And this balance is really important. Here in Charlotte, the last bad airline crash that was a commercial plane. It's pretty rare, but the last one we had we've had two in the 25 years I've lived here, or excuse me, now it's 30 years. One was a burst of air, forced it into the ground. Most of the people survived actually because it was landing. They had used up most of their fuel, and the storm weather just wasn't that far off the ground. Just dropped it straight down. The other one, unfortunately, was a plane with about 40 passengers. The pilot, she was in a rush, but she might have been told wrong information. Whatever case, she took off. The plane wasn't in balance, so the tail was much heavier than the nose. The nose pitched up, and so that tail moment arm was much greater, causing the plane to go into stall, and it was full of fuel, and it just exploded on impact. So, they weren't that high off the ground. If it exploded, I suppose some people might have survived. All right, we got a question. Yes. All right, her hand just went up for a moment. Okay, Leslie. All right, so that's that. If you want to, we won't tonight because I know people are trying to get ready for the test, but there's really great talk about torque as applies, and this is great physics of this. How do you get that big toe to be the same way, balance that frog? Well, it's the distance of that moment arm. This is a shorter distance here than out here. This is why a little baby and a little dad can be on the same teeter-totter. You move baby far out far out, give it the longest moment arm you can, and you move dad right to the fulcrum, so he doesn't have any moment arm. Okay, and you still scare him up. All right, and it goes through a complete explanation in center of gravity. You can do some calculations with that. Talk about which one's got greater moment arm and how it's flying. You're able to fly the plane and look at how much deflection. That's how much you push the elevator back or forth. There's tail moment arm, airplane A, B. That's a really long tail arm. Okay. All right. That's out of lesson 6. Now, if you would, everybody try to get Plane Maker out. Oh, there's a question. Let's go ahead and get this question. Yes. Yes, absolutely. Thank you. Absolutely. Dave Quinley just suggested, hey, aircraft, air fuel tankers, they're offloading fuel quickly in flight, so that center of gravity is changing all over the place. The Air Force, we are one of the few here in Charlotte, our Air National Guard puts out fires, and that's really a challenge for them. Few Bears, they got hit by a wind burst and caused one plane to come out of the sky, and a couple people were killed, and a couple people were seriously hurt. And but what they always talked about was just what you're saying. They're dumping off flame retardant. But I also have a former student that got his start in the Air Force, and he was refueling airplanes, C-130s. He would refuel those in flight. And you're right, you're constantly having to evaluate that. And also, by the way, they used to put water and add all this weight to them, and they would test them before we had computer simulators to see what point does it stall at what weight. Talking about a hazardous job. So, anyways, thanks for that suggestion. All right, by now, hopefully everybody's got Plane Maker up. And where do you find Plane Maker? Well, if you go into the folder from X-Plane, remember we get this off the desktop. Remember the folder on your desktop that says, Fly to Learn X-Plane. Open that up, you'll see X-Plane, but near it you'll see something called Plane Maker. And we're going to want to start that up. Okay? So everybody please do that. Give everybody a chance. Don't worry, yours is probably not going to look like this one. Let me give you what yours will probably look like. There it is. Might look like something like this if you've not used it before. If you have used it before, it'll show up the last plane you used. If you hit the space bar, if you're in the software, you hit a space bar, it might be solid. Hit the space bar again, it's in line. Raise your hand once you're up to this screen right here. Please raise your hand. Once you've got it, go in the plane maker. Also, write me a note or just raise your hand if you know you're not going to start up, i.e., my computer won't run, whatever. I would also point out you're not going to open X-Plane. You're opening up Plane Maker. That's a driver issue. If you call or tech support, they can walk you through. You might have to update your drivers there, Lisette. But you probably can open Plane Maker. Don't worry about opening X-Plane. Plane Maker really doesn't require anywhere the graphics. So if you go in the same folder that you found X-Plane, look for something called Plane Maker. Then raise your hand once you have it. All right. Now you've got this. What you're going to do, the first thing you're going to do is get the right aircraft. We're going to open, we're going to go under aircraft, then general aviation, and this is all in the curriculum, Van RVs, and you're going to select the RV10. That's this plane right here. And then you're going to save it. And this is definitely in the curriculum guide. And let me explain. We go about saving this. You're going to be studying aspect ratio. Aspect ratio is the wingspan divided by the mean chord. And you're going to have the kids calculate what the aspect ratio is. And there's a couple of these you're going to throw out because they don't fall within. They have to stay in a certain range and not in that range. But basically, aspect ratio is 30 divided by 4/8. Wingspan divided by chord. In that case, it's 6.25. Then, up here, write citizen listen. You're going to take your first name, 10, 20, 30, your first name, and you're going to make 5 copies of the RV10. You don't want to save over your RV10. That's kind of your test mule in this case. All right? So you don't want to save over that. And once we get those 5 airplanes saved, then you can go in and do this. Right now, just raise your hand once you've got your airplane saved. All you do is, and to save it is, remember, just go back into Plane Maker here. Bear with me a second while I'm just on the way. All right, so what I would do is I would do File. So right now, this is RV10. It says it right at the bottom of your screen, RV10. I would do a Save As, and that would be Mr. D50, for example. Boom, save. And then at the bottom it says Mr. D50. Now I would do it again. Save as Mr. D40. Save. Okay? Go ahead, make your 5 airplanes. Go ahead and copy them. 50, 40, 30, 20, 10. Raise your hand once you've done it. All right. Go ahead, raise your hand once you get them, guys and gals. And if you... Sorry, I got a text coming through. They very involved with our local maker community and the local engineering schools for that matter too. And the one community college, which is outstanding here, has got a fab lab. Basically, you make anything in that place. They just sent me some amazing photos on my phone. So I muted it. I'm still trying to mute it, but I can't get it to You know, here I am teaching computers, everything. I can't even mute my own phone. How sad is that? No, I got it set. You can't save yours. The reason why you can't save it, you're running it off the DVD. Please open your program off your folder on your desktop. You have to take the desktop, you have to take the DVD, like it says in the installation instructions, and copy it onto your desktop. We had to do that because of the schools. Amazing as it sounded, it costs more. Well, one, we don't charge a lot for the software. Second of all, it cost some schools more to install the software than to get the software. So we found out that a lot of times if you could copy it on the desktop, they didn't have to worry about the installation issues. And so that's what we resort to. All right. So tonight when the webinar is over, it'll take 20 minutes to 30 minutes to copy. Just copy the whole desk over. All right. Now let's go ahead. Are we doing on time here? We're still at, okay, we're not too bad. All right. Okay. Now, the next thing you're going to do is you're going to go under standard wings. And we're going to change. This is wing 1 right here, the big main wing. Wing 2 is the wingtips. All right. Sorry, we had our electric guys load for us. No worry. Yeah, if they don't take the time, if they just think they know how to do it, they don't read it, because it's not how you normally do it. In fairness to the tech guys that are trying to do 1,000 things at once. Okay. All right, now just we'll look at PlaneMaker for now so you get a gist of it. So those are the wingtips right on the back. And there you can see the wingtips are the flashing things on there. That's wing 2. Wing 1 is the main wing. All right, this is main wing here. All right, I'm going to go back to my PowerPoint. Okay. Because it's a little bit easier to see. So there we are, wing 1. So the first thing you're going to do, and on the handout you have an aspect ratio, there's a table there, and it tells you. So wing 1, you make the semi-length 25 feet. That's half the wingspan. So if that's the total of 50 feet, right? You're going to open. So open, if you can, open your name airplane 50. If you did that, then you would open up wing 1. You change it to 25 feet. That's great, but now your wings are farther out than your wingtips. So we need to go to wing 2. Change that. You don't change the length, the width of the wingtip. You just got to move them out. So we move them out to 24.95, and we change the vertical arm to 0.25 because this is dihedral. Tips are a little below because you push them farther out. Think of a V. So now we're pushing them up. And then you'd save that. Okay. So remember here in your paper, it was 25 for the first wing, 24.9 for the second wing lateral arm, and then vertical arm. Do that one and do the your name 10 foot, the 10-foot wingspan. All right. Do that, save them, then open up X-Plane, look under aircraft, general aviation, van, RVs, and you should see all the airplanes you saved. Fly your 50-footer, fly your 10-footer. Notice the distance that you have to go down the runway. Try to fly them both consistently the same way. In other words, take off full throttle, maybe keep your pointer right below the little cross. Fly both airplanes the same way. That's probably one of the hardest things to do is to be a test pilot, whether it's airplane, cars, or something, where you can do the same thing over and over identically. so they can see if it's a difference in what's changing in the car or the airplane. So raise your hands when you've got both airplanes made, and then go ahead, review how to take off, collect data, and see what the distances do. This will take a few minutes. That's totally fine. That's why I'm having you do that. David, I'm assuming you've already knocked this out, but if you've got a question, just go ahead and write it for me on there. Or if you have a question, lower your hand and then put it right back up, and I'll know, oh, you've got a question, and I'll go ahead and call you out and answer you. All right. Lisette's working on it as well. Good job. Oh, there's another question. You're done building. Okay, then go ahead and fly it, David. Go ahead and go open up X-Plane, go under aircraft, go under general aviation, select van RVs, and you should find your airplanes. Go ahead and test pilot them. All right, good. On the disc should be the disc sheet that came with your DVD. Lisette, go ahead and there'll be tech support. Randy Witt will be the guy most likely to pick up, and he'll be happy to help you. And he does this all day long. He's part owner of X-Plane, and he's a guru on that. If you got to ask anybody, he has a lot more patience than I can ever have. The perfect personality for it. Heck of a nice guy. Somehow we lost Julius. All right. John, Dana, Jeffrey, raise your hand once you've got the planes copied. And then if you've got them copied, and all right, great. And then let me know once you got them. Let's get them all copied and then see if we can get them tested down the road. Okay. Another hand's raised. Good job. Okay. Good to know. Jeffrey's just watching tonight. All right, then go ahead and raise your hand. That way we know not to wait on you, if you would mind, Jeffrey. All right, good. Okay, it's 9:09. We'll give it a quarter after 9. 6 more minutes. Go ahead. Build your airplanes. test them and see what the results are doing on them. For those people that want to share or send it to somebody else, here's the link to the first webinar. The beginning was a little quiet because I'm waiting on people to come on, but it goes on after that. All right, let me see here. Another question. Just got some more. Will this be on the web, YouTube? Yep. Probably put a couple of them on there. All right. And someone asked me, which I've never thought to do in the past, seems obvious now, but I put the slides up, PowerPoint presentations. Yeah, I'll share them with folks. We'll put them up in the classroom so you can have this. As you're flying the airplane, I'm not going to give the answer away, you're going to see this aspect ratio has tremendous impact on takeoff distance. So the question immediately becomes, well, why doesn't every airplane have the same aspect ratio? When we get what we try to get the kids to see, like in a lot of engineering, it's always a series of trade-offs. And remember, form follows function. What is the function of your aircraft? Form's going to follow that. Okay? Art for art's sakes doesn't necessarily have to follow this. Whereas engineering or architecture being a lot of art in architecture, it does. It has to have, it's got to be functional. So getting something, that's why it's always amazing. Things as beautiful, for example, as a Golden Gate Bridge, a beautiful sports car. You've got beauty in it that's also very functional. You know, probably what Jobs understood better than most. Steve Jobs. All right. Got one more minute here, and then we're going to go on to the next things. And there's worksheets, just like we said last for 5 lessons. There's a place for them to graph out the results so they can practice a scientific method. I'm a big believer that you teach the methods, the process. Just keep teaching it over and over. And that's the important thing they come out of with is the process. All right. Again, this was in here. I'm just going to batch this out. Wing 1, you do the main wing. Wing 2 is the wing tips. Okay. And the kids could adjust them by trial and error. It's just not really effective. Not a fast way to do it, but if you want to do it to begin with. All right. Now we're going to talk about wing loading. So the first one was aspect ratio, wing loading. And this is a relationship between the weight of the wing, the plane's gross weight divided by the surface area of the wing. Kind of density, but doesn't include really volume. And you're going to look at on this, there's going to be a graph where they calculate the wing loading. And first thing you got to calculate is wing area, which is the wingspan times chord, not divided by it. That's aspect ratio. Okay. And then they calculate the wing loading area, which is the weight of the gross weight divided by that wing area. All very practical applications of math. And then you can also look at wing loading in terms of, well, if we keep the wing area the same, but we change the weight, what does that do to wing loading? So you look at those relationships. And, you're going to fly, and there are going to be some performance things. Again, here we're very explicit about talking, well, here's the trade-offs. Again, function follows forms. Here's what you gain. Here's what you lose. Now, the next thing we'll talk about here. Any questions before I go on wing loading? We'll put everybody's hands down here. Any questions about wing loading? Any questions on aspect ratio and what the lab, which you're doing for those people that are flying it? All right. Let's go into power loading. Power loading, we have to, when you start talking about power, this is the weight of the airplane, how much horsepower. And this is another interesting concept for kids to get and really for adults to get. Say you do the calculations, and we have a high school advanced one that's coming out where they're going to calculate how much drag, and then they're going to calculate how much horsepower you need to overcome said drag. Well, say you do the calculations and it's 100 horsepower to overcome the drag of your airplane. That's called the brake horsepower. But that doesn't mean that's the amount of horsepower you're going to need to fly your airplane. Because the reality of it is not all of the horsepower coming out of that engine gets to be used. You lose about 20% of that horsepower because of propeller efficiency. And a bit of a trivia, the Wright brothers propellers were very efficient. We've only gotten a few percent more efficient than they were when they built those over 100 years ago. One of the reasons why the Wright brothers were able to fly first. They had very efficient propellers. They didn't have to wait for engines to get so powerful that they get around that efficiency. All right. Well, so if you need 100 horse to get over drag, you really need something like 120 because you got that 80% difference. 125. All right. So that's the first thing you notice off of it is you don't need 100, you need 125. Let me just clear this out and make sure I get this right. 100 divided by 0.8. Yeah, 125. So right off the bat, you need 124.5 horsepower because that darn propeller isn't completely efficient. And then at takeoff, you run full blast. But you don't run an engine or anything full blast all the time. You just wear out the engine. And if your engine's not running quite right, you should be very nervous that you have to run in full blast to fly. So we want to say, well, we need 125. We only want to run about 75% full power. So you got to take that 125, divide it by 0.75, and then you're going to see you come up with an answer of more than 166 horse. So you need 167 horse to get 100 pounds of horsepower. So 167 pounds of horsepower. So you can get the 100 you need to overcome drag and not wear the engine out, which of course impact fuel economy. So that's the next thing they have to think about. So we really do try to get them to think about practical things. So brake horsepower required to overcome drag, thrust horsepower, cruise horsepower. Well, and like we say, well, yeah, you might be thinking right now, wow, it takes 3 calculations just to find out how much power is needed to fly. Well, yes, engineering requires math. Don't ever apologize for that. You don't have to be a math genius. Just get a solid foundation in math. Then you get to do cool things. And math is one of the very few things you get better at the older and older you get. Okay. So they're going to do some plane construction. They're going to do all the calculations for this. Some of it's given. They can go under engines to change the maximum allowable horsepower, which then will, as you increase the horsepower, you increase your fuel consumption. And that's an issue they get into. Okay. And then once they do that, they've done power loading, then we're ready to do lesson 10. And we'll do lesson 10 next week. But lesson 10 basically is we're going to take everything you've learned, put it together, and design an airplane, really concentrating on the main wing. That's the most bang for the buck. And there's new aircraft. You identify, you brainstorm, select, model, proof of concept, on your planning side of this. What you need is some idea that gives you an advantage over everybody else, some new trick. Doesn't have to change anything, just needs to change something. All right. Then you build a prototype, test a prototype, make changes, build a new prototype. Do it over and over again. All right. When you go to actually build it, you make design specs. In this, it says 800 nautical horsepower range. That's way too high. It's 500. But it's a 4-passenger airplane. Each passenger can carry 20 pounds of luggage. Change 150 knot cruise speed. And then that'll change nautical range. And it's not 800. If you look at the handout, it's 500. And then they'll go through and using rules of thumb, actually do these calculations. And they'll have to make decisions. And we'll go through that. I have done this with 8th graders, prep students, students that are in underserved neighborhoods, and everybody. They get into this because it is very cool. You sit down and do all the calculations. And then at the end, they design a sports airplane that goes a lot faster. Okay? That's kind of where we are with this. Any questions? Folks, do we have any questions out there? All right. Well, I have to copy these webinars over. Once they're copied over, I upload them. And I'll put them up there. If you got questions, I'll see. Just let me know between now and next week. The contest doesn't start till April. I'll announce the rules and everything on April 1st. Okay? And one of y'all are going to get to build an airplane, which I think is so cool. Very happy Gamma's General Aviation manufacturers, and so happy to do that. All right. Well, if there's nothing else, Y'all have yourselves a great evening, okay? Take care, everybody. You're welcome.